The city poured that concrete in 1994, a half pipe, a flat-bottom bowl, maybe 40 feet long, built behind the Multnomah Community Center on SE Division Street in Portland because somebody on the Parks Committee thought the neighborhood kids needed somewhere to go. The kids went. For a while. Then they grew up, the ramp aged badly, and by 2018 it was just sitting there, half of it fenced off, the other half open to anyone who wanted to walk past the cracked warning signs. The plywood deck had warped. The metal coping at the lip was rusted orange. Most people who walked by it didn't even see it anymore. It had become one of those things that's so permanently broken that your eye just skips it. Lina Baráková saw it differently, but that's not where her story starts. It starts 6 months earlier, in the fall of 2022, sleeping under a tarp off SE 82nd with a wind that found every gap she hadn't thought to seal. Here's the thing about sleeping under a tarp in a Portland November. The tarp itself isn't the problem. The problem is that a tarp is a lid, not walls. Cold air moves sideways. You can block rain from above all you want and still freeze from every other direction. And you don't figure that out intellectually. You figure it out at 3 a.m. when you've been wet for 2 hours and you can't stop your hands from shaking. Lina had figured it out. Multiple times. She was 43, Croatian-American, formerly a drafter at a civil engineering firm in Beaverton that downsized twice in 18 months. She'd lost the apartment in June. The firm job had ended in March. There's a window between those two things, about 3 months of eating through savings and convincing yourself it would turn around, that she doesn't talk about much. By November, she was living rough off SE 82nd, running a camp of sorts with a woman named Patrice, who had a better sleeping bag than sense, and a guy named Dale who showed up and disappeared on a schedule nobody could predict. What Lina had that most people in the camp didn't was a background in structural drawing, not carpentry, not building. Drawing other people's buildings on AutoCAD for 8 years, which means she understood load paths and geometry in a way she couldn't always explain, but could absolutely feel. She looked at structures the way a mechanic looks at an engine, not aesthetically, just functionally. Is this holding? Why? What would happen if that failed? She'd been asking that question about her tarp setup since October. The answer was never good. The tarp camp had a particular misery to it she couldn't engineer around. Even when she got the tarp staked out correctly, even when she had the sleeping bag dry and the ground pad positioned, the cold was lateral. It came in from the sides like something patient. She'd wake up with one side of her body cold and the other warm where she'd been lying on it, and she'd flip over and within an hour the situation would reverse. You can't win that way. You're not insulated from the world, you're just rotating your exposure to it. That's the real problem she was trying to solve when she walked past the ramp the first time. So what does a half-pipe have to do with any of this? That's the question that's going to thread through everything here. Because when Lina first walked past that ramp in late October, she wasn't thinking about shelter. She was thinking about whether the fence had a gap she could squeeze through to get to the water spigot on the far side of the community center lot. It did. She did. And while she was over there, she walked up the apron of the ramp and stood on the flat-bottom section and looked up at the curved walls on both sides. 12 feet high at the lip, solid plywood construction over steel framing. The deck boards had gaps where they'd pulled away from each other as the wood dried and swelled through too many Oregon winters, but the structure underneath was sound. She stomped on the flat bottom. Nothing flexed. That plywood was 3/4 inch, minimum, probably layered. The way skate ramps are built, sheet over sheet with the grain alternating, glued and screwed on every overlap. Serious wood, the kind of wood that doesn't move. She stood there for maybe 10 minutes. Not planning anything yet, just looking. There was something about the quality of the silence down there. The flat bottom of a half-pipe sits maybe 4 feet below the lip on each side, so you're sort of sunk into the structure. That caught her attention. The street noise from Division was muffled. The wind she'd heard over the fence was gone. It was the same October air, same temperature, but it felt different because it wasn't moving. She went back to the camp that night, slept under the tarp, woke up cold at 3 a.m., lay there thinking about the bowl. Let me ask you something, because this is the question that actually matters here. What is a half-pipe? Geometrically, most people would say it's a curved ramp, 2 curved walls with a flat section between them, lips at the top. That's what it looks like from the outside, and that's how it works as a skate structure. But here's a different way to think about it. A half-pipe is two partial cylinders connected at the base. The curved walls are concave on the inside, and that concavity, that bowl shape, does something very specific when you're thinking about heat. Flat walls radiate heat outward in all directions from their surface. They don't hold anything, but a concave surface faces inward. The curve faces itself. If you're standing at the bottom of a half-pipe with a heat source, even a small one, the walls are all pointed at you, not away from you. The geometry itself is concentrating. This isn't magic. It's the same reason a parabolic dish antenna focuses a signal. The curved surface bounces energy back toward the focal point. In a half-pipe, you're at the focal point. Every surface is angled toward the center of the bowl. Not dramatically, not with engineering precision, but with consistent bias. The bowl wants to collect things. Think about what that means for heat. Flat walls in a conventional shelter, a tent, a lean-to, let heat escape in all directions equally. The walls are neutral. The half-pipe walls are not neutral. They are on a slight bias toward the person sleeping at the bottom, not because anyone designed them that way for warmth, but because the geometry that makes a half-pipe work for skating happens to be the same geometry that makes a small space want to keep its heat. Lina didn't think about it in those terms, not that first night. What she thought was, this feels warmer down here than it does on the street. She was right. The night she actually slept in it was late November, and she'll tell you she didn't plan it. She'd come back for the water spigot a few more times, and one evening the wind off the Willamette was doing something savage, and the tarp camp was miserable, and she just went through the fence gap and climbed down into the bowl. She had her sleeping bag, a wool blanket she'd gotten from a donation bin 2 weeks earlier, a change of clothes stuffed into a garbage bag for a pillow, and a composition notebook because she'd started writing things down in October and hadn't stopped. Down in the flat bottom of the bowl, in the dark, she noticed several things in sequence. First, the wind. Gone. Completely gone. Up at the lips, she could hear it still going. She could hear it moving over the open throat of the ramp above her. Down where she was, nothing. That absence, the absence of wind, is not a small thing. Wind doesn't just feel cold. Wind actively strips heat off your body by moving the warm air layer your skin creates away from you before it can do its job. Your skin is constantly producing a thin envelope of warm air. In still air, that envelope persists. In wind, it's constantly swept away, and you have to keep generating it. Take the wind away, and your body becomes its own heater, with no opposition. Second, the sound quality. It's a strange thing to notice when you're trying to stay warm, but the bowl had an acoustic character. The curved walls reflected sound back toward the center, the same way they reflect heat. The city was muffled. She could hear her own breathing clearly. She said it felt like being inside something rather than beside something. Third, and most important, by the time she'd been in the bowl for an hour, it was noticeably warmer than the air outside. Not dramatically, not warm, but the differential was real, and she could feel it. She slept until 6 a.m. First full night in weeks. The morning after, she sat in the bowl for a while before leaving and did what she'd done for 8 years with other people's structural problems. She thought about failure modes. What would make this not work? 3 answers came fast. The open top, the ramp was open to the sky, and all that warmth she'd felt accumulating overnight was rising out the throat into the cold air. The concrete pad underneath. She'd been sleeping on the wood deck which sat above the concrete on steel legs, but the cold from below was still finding her through multiple layers. And the gaps in the deck boards, thin slots where the riding surface planks had separated, letting cold air infiltrate from above, fall into the bowl, pool. She wrote all 3 down. November 28th, 3 problems, numbered. Then she numbered 3 solutions. Problem 1, open top. Solution, cover it. Problem 2, cold floor. Solution, insulate from below. Problem 3, deck board gaps. Solution, seal them from above or below. She'd given herself a work order. Something about writing it down in numbered order, she said this, made it feel like a real project instead of a desperate situation. She'd written work orders for 8 years. She knew what a solved problem looked like on paper. This was the same shape. Now here's where it gets interesting. Because closing the top of a half pipe, sealing the open throat, sounds straightforward. Just put something over it, and the impulse most people would have is to drape a tarp over the lip. Lina tried that. December 1st, she scavenged a 10 by 20 blue poly tarp from the construction debris pile 2 blocks over on 74th, climbed up to the lip of the ramp, which is a physical task in itself. Those lips are about 12 feet off the ground, and the coping is rusted and uneven, and you need to be careful with where you put your hands, and draped it down into the bowl. The problem with a tarp over the throat is tension. A tarp that spans an opening that wide wants to sag into the bowl, and once it sags, it collects rainwater. And once it collects rainwater in a Portland December, it's collecting maybe half an inch of rain every 2 days, and that weight pulls the tarp further, and eventually you wake up with a cold puddle on your chest. This happened December 3rd. The tarp had collected maybe 2 gallons of water overnight. The center of it had dropped down to within a foot of where she was sleeping. She woke up because she heard it, the specific sound of water weight shifting, and she had maybe 4 seconds to roll sideways before it let go. She was wet, cold, furious. What she needed wasn't a drape, it was a rigid cover, something that could span the opening without sagging, something with structural integrity across a 14-foot gap. She thought about it for 3 days, walking the neighborhood, looking at the discard stream. The city of Portland in December 2022 had active construction on 6 blocks within half a mile. She knew this because she'd been walking them for weeks, some corrugated metal panels stacked against the back of the Value Village on Foster, a pile of 2x4 lumber in an alley on 80th with a free sign that had been getting wetter for 2 weeks. The lumber was what she kept coming back to. Here's the geometry. The ramp throat is roughly 14 feet wide. If she could run parallel beams across the width at intervals along the 40-foot length, she'd have something to lay panels on. Like a roof, she drafted enough residential work to recognize a simple shed roof assembly when she saw one in her head. 8-foot 2x4s, sistered end to end, spanned 14 feet with overlap at the center. She needed 12 boards, 6 beam pairs. She carried them in 2 trips, lashed the beams to the coping with galvanized wire in figure 8s, pulled tight with needle nose pliers, then laid 8 corrugated metal panels across the beams, overlapped like shingles, 1 gap left intentionally at the far end for air exchange. CO. She'd thought about CO before she'd thought about anything else. She bolted 4 of the 6 beam joints with carriage bolts she found in the construction debris pile, wired the other 2. December 9th, it rained. She woke up dry. The cold floor was next. Concrete at ground level in a Portland December holds ambient ground temperature, somewhere in the mid to upper 30s at its surface. The ramp structure sits about 4 inches off that pad on its steel legs. The airspace between the ramp floor and the concrete pad is a cold zone, cold air pooling there, conduction pulling heat down through the riding surface plywood. She needed to break that conduction path. What she used was cardboard, an enormous quantity of it. She spent 2 full days pulling flattened boxes from the recycling bins and dumpsters behind the grocery outlet on Foster, the Home Depot returns area on 82nd, and the loading dock of the furniture store on Woodstock. She was specific about the cardboard she took. Double wall only. Not pizza boxes, not cereal boxes, the thick industrial stuff that comes around appliances and furniture, the boxes that are themselves a structural product. She layered it 6 inches deep across the entire flat bottom section, cutting pieces to fit and overlapping the edges. She tucked the cardboard up into the curve at the transition ends, wedging it against the curved plywood walls where the floor met the wall. Then she laid a piece of salvaged vinyl flooring she'd found rolled up against a dumpster on Clinton. Someone had renovated a kitchen and put the old floor out, over the top of the cardboard to keep it from shifting and getting wet from above. 6 inches of double-wall cardboard. That sounds trivial. It's not. Dry cardboard is mostly air. The corrugated structure, the interior fluted layer between the flat-face sheets, is roughly 90% air by volume. Air conducts heat poorly. Still air, trapped in enclosed channels too small for convection to start, is genuinely insulating. 6 inches of it, compressed but not crushed, is somewhere around R6 to R9, depending on the density and whether the corrugations are running perpendicular to the heat flow path. That's not great by building code standards. It's better than nothing by a margin that kept her alive in December. She also put cardboard on the curved walls, layers of it, held against the plywood with wire loop through the gaps in the deckboards above and pulled tight around the cardboard sheets. It sagged in places and peeled away in corners. The wire left it looking like something a bird might build if birds had engineering degrees. But it broke the conduction between her body heat and the cold plywood, and that was the only job it had to do. Her first night after the floor fix, she slept with just the sleeping bag and woke up warm enough that she'd sweated through the liner. She wrote in the notebook, "Floor problem solved. Still need to address the walls better." Heat source. This is where most people get stuck, and it's where the conversation gets genuinely interesting, because the question of how to heat a small sealed shelter has about a dozen answers, most of them wrong. Wrong answer. 1. Open flame inside. This is the default. A small fire, a cluster of candles, a kerosene lamp. In a small sealed shelter, any open combustion source consumes oxygen and produces carbon monoxide. The half-pipe bowl, at this point fully covered, was roughly 800 cubic feet of enclosed air. She'd calculated this roughly from her arm span measurements, and 800 was a conservative number. It might have been closer to 650. A single candle burning for 8 hours in 800 cubic feet of tightly sealed air will meaningfully deplete oxygen and raise CO to levels that can cause headache and confusion. Multiple candles are faster and worse. She'd seen what CO did to Dale over the winter, who'd been running a propane burner in a tent and woke up sick for 3 days in a row before someone told him what it probably was. She was not going to die for warmth. What she used instead was something that has a reputation online as either clever or completely useless depending on who you ask. 2 terracotta flower pots, a large one, and a tea light candle. A single tea light produces about 30 watts of thermal energy. Burn it in open air, and most of that heat rises and disperses immediately. Place a small terracotta pot upside down over the candle, and the clay absorbs the heat, soaks it up slowly, holds it, radiates it outward at body level instead of letting it shoot straight to the ceiling. The larger pot over the smaller one creates an air gap that slows the transfer rate further, extending how long the outer surface stays warm after the candle goes out. It's not 30 watts becoming 300 watts. What it does is change the distribution of the energy you have. Instead of a quick burst rising and escaping, you get steady radiation from a surface at ground level, pointing at you. In a sealed, insulated 650 cubic foot bowl with concave walls and 6 inches of cardboard between you and a concrete pad, 30 watts is enough to maintain a temperature differential. Outside at 34 degrees Fahrenheit, body heat plus clay-radiated warmth plus dry insulation will hold the interior somewhere between 44 and 50 degrees Fahrenheit through the night. That's not comfortable. That's survivable. In Portland, in December, that's everything. She ran 2 tea lights. Different corners of the bowl, clay mass distributed. Gap panel cracked 2 inches. Enough air exchange, not enough to kill the warmth. She spent about 40 cents a night. Dollar store on 82nd, 100 tea lights for $3 and change. Let me step back and ask the question that's been forming here. Because by mid-December, Lina had a sealed, insulated, partially heated shelter. The numbers were real. The geometry was working in her favor. She'd solved all 3 of her original problems, the open top, the cold floor, the wall conductance, and she'd arrived at a heat source that wasn't going to kill her in her sleep. And the obvious question is, did she stay? She did, but it got more complicated. The community center had a maintenance staff, 2 guys Wednesday and Friday mornings. She'd been aware of this since October. She knew the schedule because she'd been timing her water spigot trips around it. What she hadn't thought through carefully was the visibility of the project from the lip of the ramp. The beams were visible from above. Obvious, even, parallel 2x4s spanning the throat of the ramp, with corrugated metal panels laid across them. If you walked up to the fence line and looked over, you'd see a roof where there used to be an open ramp. It was not subtle. She'd assumed nobody looked. This turned out to be right for about 3 weeks. But December 17th, 2022 changed everything. Portland gets ice maybe twice a decade in a serious way. This was one of those times. Freezing rain started overnight on the 16th. Temperatures dropped to 22 degrees Fahrenheit by the time she woke up, and everything on the street was coated in half an inch of clear glaze ice by dawn. Power went out in parts of SC Portland. The emergency shelters filled up completely by 7 p.m. the night before. She knew this because she'd checked. She'd walked down to the Salvation Army on Division, and there was a line outside the door, and the person at the door said they were at capacity. She went back to the bowl. The corrugated metal roof held the ice load fine. Metal panels shed sheet ice as it forms. The smooth surface doesn't give it much to grip, and the weight of the accumulating ice slides it off before the load gets serious. That part she hadn't worried about and didn't need to. The problem was condensation. When you're sleeping in a sealed space that's 47 degrees Fahrenheit inside and 22 degrees Fahrenheit outside, you have a temperature differential of 25 degrees across the walls. Every time you breathe, you're putting warm, moist air into the enclosure. A human at rest exhales something like half a liter of water per hour. That moisture migrates outward through the air, hits the cold surfaces, the plywood walls, the underside of the corrugated roof panels, and condenses. Water on every cold surface, inside the shelter. The cardboard on the walls, which she'd positioned against the plywood, was absorbing that condensation. All night. The outer face of the cardboard was cold because the plywood behind it was cold. Moisture condensed on the cold face, migrated into the cardboard fibers, and the cardboard got wet. Wet cardboard loses its insulating properties fast. Wet cardboard is dead weight. The air channels collapse, the fiber is matte, and what was once R8 becomes R maybe 2, and you can feel it. Not gradually, but in the specific way a cold thing feels different from an insulating thing. A cold thing has a temperature. An insulated thing has an absence. She woke up at 4 a.m. to the cold radiating off the wall beside her, the wall where her cardboard had gone limp and damp. She pulled it off, turned the sheets over. The side facing inward, the room facing side, was drier than the side against the plywood. She put it back with the dry side in, bought herself 2 hours of marginal insulation. By morning, the cardboard on 2 of the 4 walls was compromised. She'd lost a meaningful portion of her wall system in one night. She fixed it on December 19th. The fix was vapor barrier, specifically garbage bags. She went through 11 33-gallon black garbage bags, cutting them open along their seams into flat sheets, roughly 20 by 30 inches each. She layered them against the plywood walls, overlapping edges by 4 inches, and secured them with wire ties through the deckboard gaps. The plastic went on the cold side, between the cold plywood and the cardboard batting. This way, when warm, moist air from inside the shelter migrated outward through the cardboard and hit the cold surface, it hit the plastic before it hit the wood. Condensation still happened. Physics insists on it, but it happened on the plastic surface where it beat it up and ran down to the floor, not inside the cardboard fibers. Dry cardboard. Back to R8. Wall system restored. This is the same principle as a house vapor barrier. The plastic sheeting inside your walls, between the studs and the drywall, that most people have never thought about and wouldn't recognize if they saw it. It's doing one of the most important jobs in any wall assembly. It keeps the insulation dry. Wet insulation is just dead weight in a house wall or a plywood bowl. She spent a full day reorganizing the wall system with the garbage bag vapor barrier in place, plastic against the plywood, then 2 layers of cardboard, the inner layer's dry face pointed inward. She secured everything with ratchet straps looped through the deckboard gaps. She'd borrowed them from Dale weeks earlier and he hadn't asked for them back. The next night, December 20th, the temperature dropped to 19 degrees Fahrenheit. Her interior, she measured with a dollar store thermometer hung from one of the ramp beams, held at 44 degrees Fahrenheit through the night. 19 outside, 44 inside. On body heat, and 2 tea lights and dry cardboard behind garbage bags in a curved plywood bowl. I want to sit with that number for a minute. 44 degrees, because I think most people hear that and think, that's barely anything. It's not warm. Nobody is claiming it was warm. But here's what 44 degrees Fahrenheit means when it's 19 degrees Fahrenheit outside and you're sleeping rough. The human body at rest produces about 80 watts of heat. In open air, at 19 degrees Fahrenheit, Those 80 watts are gone instantly. The cold pulls them away faster than you make them, and eventually your core temperature starts dropping. In a sealed, insulated space, those 80 watts don't escape as fast. The space is finite. The walls have resistance. Add 60 watts from 2 tea lights through clay thermal mass, keep the floor insulated, keep the walls dry, and you land somewhere in the mid-40s. She measured it. That's what she got. The geometry helped in ways she was still figuring out by December. In a square shelter, your radiant heat goes to the flat walls, and that's where it stays. In the bowl, the curved surfaces were bouncing some portion of that heat back toward the center where she slept, the way a reflector behind a lamp pushes warmth in a specific direction. Not dramatically, not enough to measure, but the bias was real, and on a 19 degrees Fahrenheit night, every degree of bias mattered. She was there through January. January wasn't as brutal, temperatures mostly in the high 20s to mid-30s at night. She refined things, added newspaper between the cardboard layers, filling the gaps where the sheets didn't quite meet at the edges, started keeping a canteen of hot water inside the sleeping bag, filled at the community center spigot in the morning while the maintenance guys weren't there. A hot water bottle at body temperature next to your core holds useful heat for 4 to 5 hours. She ran it like a relay, in the bag from 10 p.m. to 2 a.m., then a brief wake-up, refill from a thermos she'd kept warm, back in. It sounds exhausting. She said it felt like having a system. For the first time in months, she was sleeping through the night. Dale came by once in early January and stood at the lip and looked down at what she'd built. He said it looked like the inside of a place. She asked what he meant. He said most places they'd been sleeping looked like the outside of a place. This looked like the inside. She wrote that down. The maintenance guys found the setup in the 3rd week of January. She'd known it was coming. She'd been thinking about it since she put the beams up. There was no version of this where the community center staff didn't eventually notice a roof where there used to be an open ramp. She'd just hoped it would be February when the join waitlist spot came through, so she wouldn't have to have the conversation at all. It was Gerald who found it. That was his name, she asked him eventually. Gerald, a heavy-set man, maybe 55, with a Parks and Recreation logo on his jacket and a radio clipped to his belt that he never seemed to use. He came on a Wednesday morning at the usual time, and she heard him at the fence line, and she came out from under the beams and stood in the flat bottom and looked up at him. He stood at the lip and looked down at what she'd built and didn't say anything for a long time. Then he said, "You put a roof on this thing." She said she had. He looked at the beams, the wire lashing at the coping, the overlapping corrugated panels. The one gap she'd left cracked open for air exchange. He walked along the lip to the far end of the ramp and looked at that gap for a moment. Then he walked back. He said, "How long has that been there?" She said, "Since December 9th. He looked at the cardboard and the vinyl flooring in the flat bottom. He looked at the 2 clay pots in the corner. He looked at her notebook, which was sitting on top of the sleeping bag. He went back to his truck. She stood in the bowl and waited. He came back 10 minutes later and said, "Parks is going to want to clear this when they do their January sweep. If it's still here, I have to call it in." She said, "Okay." He said, "The sweep's running late, probably closer to February." He left, never called it in, as far as she knows. She doesn't know why he did what he did. She didn't ask, and he didn't explain. She's been around enough people in enough situations to know that sometimes people just don't want to be the thing that ends something that's working. She thinks he could see that it was working. She thinks maybe that mattered to him. She moved out February 6th. Not because of a sweep. She'd checked the online calendar and the sweep had been pushed to the 14th. But because a spot opened at a transitional housing program on Clinton Street through Join. She'd been on the wait list since October, before she'd even found the ramp. She called Join from the community center phone the morning of the 5th. They told her a room was available starting the 6th. She hung up the phone and stood outside for a minute in the parking lot. Then she went back to the ramp and packed her things. She did not dismantle the setup before she left. She left the beams, left the panels, left the cardboard floors, which had compressed into a dense mat by February and were still dry under the vinyl. Left the clay pots in the corner with 4 unused tea lights inside them. Left the dollar store thermometer hanging from the ramp beam. She thought about another person finding it, whether it would make sense to them the way it had made sense to her. Whether the geometry would do for someone else what it had done for her, whether they'd understand the vapor barrier, the gap, the reason the pots were where they were. She decided to leave a note on a piece of cardboard in black marker wedged into the corner where the clay pots were sitting. It said, "The gap in the panels needs to stay open. Keep the cardboard dry." She got a job in March, an estimating position at a smaller civil firm in Northeast Portland. Less AutoCAD, more spreadsheets, which she'd been out of practice on, but the structural intuition came back fast. The people there didn't know where she'd spent December and January, and she didn't tell them. It wasn't relevant. What was relevant was that she could read a structural drawing and work out material quantities and catch errors in other people's load calculations, which she could do because she'd spent 8 years doing it and 2 months applying it to a plywood bowl in the rain. She still has the composition notebook. She showed it to me, the pages from November and December, the curved dimensions measured in arm spans, the 3 problem list from November 28th with the 3 solutions written underneath. Wind protection, bowl geometry, cold floor, cardboard, cold walls same plus vapor barrier, heat source, clay mass plus small candle, minimum CO risk. The handwriting is very calm for someone sleeping rough in 30-degree weather. I asked her about that. She said she wasn't calm, she was cold. But cold doesn't change what the problem is, and knowing what the problem is, actually knowing it, writing it down, giving it a number, is different from just feeling it. You can feel something and not know what to do about it. You can know a problem and solve it. That's the distinction she was working with. The ramp is still there. The beans she left are still across the throat, last she heard. She hasn't gone back to look because she's not sure what she'd feel, and she's also a little superstitious about it. She thinks if she goes back and it's gone or swept or just empty, it'll feel like something she'd rather not name. But she's also not sure she wants to go back and see it occupied, because then she'd be looking at a person in a situation she knows too well, and she'd want to help, and she doesn't know if she could help in a way that was actually useful. She said, "The note is probably gone, but the geometry is still there. The geometry doesn't care who uses it." That's the thing about a shape. You pour concrete in 1994, and some of it ends up being a bowl that a community center doesn't know what to do with for 28 years. Then one November, someone who thinks in load paths looks at the curve and doesn't see a ramp, sees a wall, sees something that's pointing toward its own center, sees something that's been on the right side of the warmth problem all along, just waiting for someone to close the top. The city built the bowl. She figured out what it was for.